So now let's go ahead and take a look at yet another example of using completion stage methods in the context of our CompletableFutures variant of the ImageStreamGang case study. And this will be looking at another method that's part of the case study implementation called applyFiltersAsync. I think you can probably get a sense of what that's going to be doing. It's going to be applying the image transforms asynchronously. So this is what gets done. This behavior, this applyFiltersAsync behavior, is called in the context of the flat map intermediate operation, which comes after we've finished downloading things asynchronously. So flat map calls applyFiltersAsync. And as you can imagine, that's going to asynchronously filter the images and store them into files on the local device. As with the previous examples, it's going to be returning a CompletableFuture to an optional image, which will either have a value if it's actually done a transform because the image originally was not cached. But if the original image was cached, then everything gets ignored. And as we've talked about before, we use flat map because we're going to get back more images than we gave in, because we're giving in a downloaded image that comes as the input to the input stream of flat map. But then after applying n transforms, we're going to have n times m resulting transformed images, where m was the number of images that came in to begin with. So what flat map does, as you may recall, is it flattens everything. So we end up with a stream of filtered and stored images in a single output stream, which will have more elements than it had coming in because it's n times m. What we get back here is a stream of completable futures to optional images, which will have a value if the image is being filtered and stored, or will be empty if it had been cached up the chain of calls here in the Fluent interface chain. So here's what applyFiltersAsync looks like. You can see that this method is in the ImageStream CompletableFuture 1 file. And it, of course, asynchronously filters the images and then stores them into files. What it does internally is it takes the list of filters and it converts that into a stream. So let's say we have 3 filters or 3 transforms, as I call them in your assignment. We have 3 image filters. We stream that. So now we have a stream of these filters. And then we're going to go ahead and call the map method. And what map's going to do is it's going to take each filter in the stream. And then when the image future has finished, in other words, after the image has finished downloading, when that's triggered, we're then going to call the Java CompletableFutures framework will call thenApplyAsync, which is that completion stage method, on that completed image future. And that will then go ahead and register the action that's shown here. Again, this action is not run right away. It's only run after the image future completes. So we're using all these various mechanisms together to really nice effect in order to be able to defer the processing until just the right time. Now, this is a bit more complicated action that gets registered, but what it's doing is it's using the image optional, which again will be used to ignore cached images. So let's say, just for sake of argument, that it's a non-cached image, so it's actually going to do some work. In that case, when the map method is called, the map method is also given a lambda expression. And what will happen here, if the image is non-empty, then we're going to asynchronously filter the image and store it in an output file. So there's a little factory method here called makeFilterDecorator with image, and we give it the filter we want to apply and the image we want it to be applied to, and we tell it to go ahead and run. And so that'll create a little object that's basically a decorator, and that will go ahead and apply the filter to the image, which will ultimately filter or transform the image and store it in a corresponding output file. And this uses something called the decorator pattern. We don't have time to go through the decorator pattern in detail, but it's a really cool technique that we use here in order to be able to transparently wrap filters or transforms around image objects that know how to write the contents to an output file. Once again, we have a getExecutor factory method here just to give us some flexibility in deciding where the computations will take place. In this particular case, they're going to run in a worker thread in the common fork join pool. Now, what will happen here is that thenApplyAsync is going to return a completable future that will be triggered when the image has been filtered, and stored. So you can see how we're kind of chaining all these things together. And of course, if it was empty in the first place because it had been cached, then that will return a completable future to an empty optional. And so you can see here that applyFiltersAsync returns a stream of completable futures to optional images. And the stream is done here so that we can have basically a stream of transformed objects that correspond to the filters that have been applied to them. And then that's going to get merged together by flat map. Notice that there's no terminal operation here. There's nothing here that's like collect or anything. We're going to collect in a different way later down the chain. So we just return a stream, and that's perfectly okay. You don't have to have a terminal operation everywhere, as long as there is one terminal operation at the end of the whole chain of processing. So you can see here that flat map is going to end up get back a stream of streams, and it flattens it into a stream. So it got back a stream of streams of completable futures to optional images, and then it basically flattens it to be a stream of completable futures to optional images. And this stream that we get, the stream of completable futures to optional images, will then be processed by collect, as we're going to talk about in the next couple parts of the lesson.